Artificial intelligence is scaling faster than the hardware beneath it, and that may become one of the biggest limits in the entire industry. Because AI does not just need better models, it needs more chips. And right now, the chip system behind artificial intelligence is under pressure. Artificial intelligence usually looks like software. A chatbot improves. An image model gets stronger. A coding assistant becomes faster. A company launches a smarter system. From the outside, the story looks digital. But underneath that digital surface lies something physical, expensive, and increasingly difficult to scale. Chips. Modern artificial intelligence does not run on abstraction alone. It runs on processors. And the most advanced AI systems run on very large numbers of advanced processors at the same time. That is why the next great constraint in artificial intelligence may not be the model itself. It may be whether the hardware system beneath the model can keep up. This is the AI chip supply crisis. Not a collapse, not the end of AI, but a structural pressure point that is becoming harder to ignore. Because the AI boom is now moving faster than many parts of the chip system can comfortably support. To understand why, we need to begin with one fact. Artificial intelligence is computation heavy. Large AI systems require enormous amounts of parallel computation during training. Then, after training, they require continuous hardware support for inference. That means AI demand does not end when a model is released. It returns again and again to the same foundation. Compute. And compute means hardware. More specifically, advanced chips. This is where the pressure begins. The world does not produce unlimited quantities of the most advanced AI processors. These chips are not generic parts that can be substituted easily. They depend on highly specialized design, highly concentrated manufacturing, advanced packaging, global logistics, and infrastructure-ready deployment. And many of those layers depend on a small number of companies and locations. That means the entire AI economy is leaning on a narrow industrial chain. If demand rises faster than that chain can expand, the result is not theoretical. Delivery times stretch, prices rise, priority access becomes strategic, and scaling slows for everyone without enough leverage. That is why the AI chip supply crisis matters. The public sees models. The real bottleneck often sits beneath them. Now consider the first part of the problem. Concentration. A large share of advanced AI hardware depends on a relatively small group of companies. Design leadership is concentrated. Some of the most important AI chips in the world come from a limited number of firms capable of building processors optimized for modern machine learning. But concentration does not stop there. Manufacturing leadership is concentrated too. Even if a chip is designed successfully, someone still has to produce it at advanced nodes, with the yield and precision required for serious deployment. Then comes equipment. Advanced fabs do not run on generic industrial tools. They depend on extremely specialized machinery from a very small group of suppliers. Then comes packaging and advanced integration, which matter enormously in the AI era because performance depends not only on the chip itself, but also on how it is combined with memory, connected to other processors, cooled, and prepared for deployment. So when people hear the phrase chip supply, they often imagine one factory and one output line. The reality is much more complex. The chip system is a stack, and each layer of that stack can become a bottleneck. This is why the crisis is not just about production volume. It is about bottleneck density. The world has built a system in which many of the most important AI ambitions depend on a chain that is both global and concentrated. That is a dangerous combination. It is global, which means it is exposed to logistics, trade restrictions, regional shocks, and geopolitics. And it is concentrated, which means substitution is hard. That combination creates fragility. Now consider the second part of the problem. Time. Software scales fast. Semiconductor systems do not. A model can improve in months. A product can launch quickly. A company can raise money on the promise of AI growth almost overnight. But adding advanced chip capacity takes time. A factory takes time. A tooling line takes time. A packaging expansion takes time. A new supplier relationship takes time. Qualification takes time. Yield improvement takes time. This creates a mismatch. AI demand rises quickly. Chip capacity rises slowly. And that mismatch is one of the defining tensions of the current market. The industry wants to move at software speed. The hardware chain moves at industrial speed. And industrial speed is slower. That gap matters, because the AI race rewards those who get there first. The firm that gets enough chips first can train earlier, deploy earlier, serve more users, experiment faster, and signal more momentum. That means chip access is no longer a background procurement issue. It becomes strategy. The third problem is competition. AI companies are not the only ones demanding advanced chips. Cloud providers want them. Hyperscalers want them. National AI programs want them. Research labs want them. Enterprise AI platforms want them. Data center operators want them. The result is a contest over limited high-value hardware. And this contest is not purely commercial. It is strategic. A company with access to chips can scale faster. A company without enough chips can fall behind, no matter how strong its software appears. A country with access to advanced hardware can build meaningful AI capacity. A country without it becomes more dependent on stronger ecosystems. This is one reason why semiconductors have moved from being an industrial topic to a geopolitical one. Because when the most important growth industry in the world depends on a narrow hardware base, chip access becomes power. Now consider what an AI chip means in practical terms. It is not just a chip in isolation. It must be integrated into servers, connected through high-speed networking, installed into racks, fed by power systems, cooled by advanced thermal environments, managed through software, deployed inside data centers that can actually support dense compute. This matters because even when chip supply improves, other layers may still slow deployment. You might get the processor, but not the packaging. You might get the hardware, but not the power. You might get the server, but not the rack-ready facility. You might get the chips, but too late to win the cycle. That is why the phrase chip supply crisis is broader than simple factory output. It includes the whole chain: design, manufacturing, packaging, logistics, installation, operational readiness. Weakness in one layer affects the rest. This is also why AI firms are behaving differently now. They are not just building models and hoping infrastructure appears around them. They are trying to secure the hardware path early. That can mean long-term supply agreements, strategic partnerships, cloud commitments, custom chip programs, capital raises justified by compute access, closer relationships with infrastructure providers. This is the deeper industrialization of AI. The market is moving from experimentation to procurement warfare, from software promise to hardware leverage. And that changes the economics of the whole field. For years, public attention focused on intelligence itself. Can the model reason? Can it generate? Can it automate? Can it transform industries? Those questions still matter. But the more immediate question for many companies has become simpler. Can we get enough chips? That is the question beneath the hype. Because without enough hardware, the rest becomes slower, more expensive, and more dependent. This is where the connection to everything else becomes visible. The data center race depends on chips. The energy war behind AI depends on chips being installed into power-hungry facilities. The sovereign AI stack depends on chip access at multiple layers. The rise of AI nations depends on whether countries can secure enough processors to avoid dependence. Every infrastructure story eventually hits the same foundation: hardware. And one of the most important hardware layers in the AI era is advanced chip supply. This is also why chip scarcity creates asymmetric outcomes. Not every company needs the same quantity. Not every company can pay the same price. Not every company has the same negotiating power. Not every company can wait through delays. The biggest players often gain an advantage because they can commit capital earlier, secure supply earlier, and absorb cost more easily. Smaller firms face a different reality. Even if they have strong ideas, they may not get enough hardware at the right time. That means scarcity can reinforce concentration. The best software does not always win. Sometimes the best supply player wins. That is one of the least glamorous but most important truths of the AI era. Infrastructure can overpower elegance. Procurement can overpower speed. Industrial leverage can overpower product momentum. Now widen the frame. At the country level, the same logic applies. A nation that depends entirely on foreign chip access may be able to participate in AI, but not fully shape it. A nation that can influence design, production, procurement, and deployment gains more strategic room. This is why governments are now deeply focused on semiconductors. Not because chips are new, but because chips have become the foundation of the next layer of national power. Artificial intelligence is not only a software market, it is an industrial capability stack. And chips sit near the center of that stack. This means the AI chip supply crisis is not just about shortage. It is about control. Who gets access first? Who gets enough? Who gets delayed? Who gets priority? Who gets priced out? Who remains dependent? These are strategic questions, and they explain why the chip conversation feels so much more urgent than it did just a few years ago. The urgency is not just that AI is popular, it is that AI is now structurally dependent on a small number of hard-to-replace industrial systems. That is what makes the current moment so important. The market is discovering that digital transformation still depends on physical reality. A model may live in the cloud, but the cloud lives in buildings. Those buildings run on servers. Those servers run on chips. And those chips come from a narrow, expensive, politically exposed industrial chain. That is the real architecture beneath AI. If AI demand keeps rising, the industry will try to respond. It will expand manufacturing, expand packaging, invest in more data centers, secure longer-term contracts, push custom silicon efforts, optimize models to reduce compute intensity, improve inference efficiency. All of those responses matter, but none of them eliminate the core reality. The AI boom has reached the point where chip supply can shape the speed of progress itself. That is the crisis, not a dramatic collapse. A structural friction point powerful enough to determine who scales and who stalls. Because in the next phase of artificial intelligence, better ideas alone will not be enough. The winners will need access to processors, fabs, packaging, logistics, energy, and deployment capacity. They will need the hardware path, not just the software path. And that means the future of AI may depend not only on what the models can do, but on whether enough chips can be designed, built, delivered, and installed to keep the entire system moving. That is the AI chip supply crisis, and it may become one of the defining limits of the AI age.